Hello and welcome to my channel. My name is Ashish Mahamuni, and in this video we are going to look at virtual threads feature of Java 21, which is currently available in preview channel. Since JDK 19 they have started first preview edition of virtual threads. Now it's I guess second preview edition. Let's look at first what is the difference between platform threads and virtual threads. So platform threads, as most of us who are using Java for a very long time, should be already aware of platform threads. Package Java lang thread API, we create thread t equal to new thread, we pass runnable task, and we do t.start. These are platform threads. They are just a thin wrapper around OS thread. Just have one-to-one mapping with OS threads. Let me show you the diagram. Yeah, so these are platform threads that we are using for many years. They have one-to-one mapping with OS operating system threads. In fact, they are just thin wrapper around operating systems. They run Java code on underlying OS thread, and in fact, for lifecycle management, they completely rely on OS thread. And because of which, number of platform threads that we can create are limited to number of OS threads. Creating platform threads and maintaining them is very resource intensive. Hence, we use thread pools for efficient management of platform threads, where these OS threads are used and again mapped to uh, your platform thread. So let's look at this diagram again. So when we create new thread, it is automatically creates operating. It is automatically creates a wrapper around OS thread, and you can clearly see one-to-one mapping between platform and OS threads. Now let's go ahead and see why there was a need of virtual threads. So as we already discussed, virtual threads these are available. They were available since JDK 19, and we already discussed this. Main trigger was to create lightweight, simple thread per request scale near optimal hardware utilization for server application. So there was a requirement when microservice architecture got evolved in terms of scaling and to utilize your hardware near to optimal. This was the requirement, and because number of platform threads can be there was a limit because of OS thread, right? Number of OS thread can be created. That was the main trigger point to create these virtual threads. So both structured currency and virtual threads that would add good value in modern microservices applications. To support backward compatibility, Java virtual thread also uses existing Java lang thread API, so that adoption of virtual thread might happen with minimal change. One goal is to enable easy troubleshooting, debugging, profiling of virtual threads with existing JDK tools. So many of us using Steam APIs might have noticed, and that is because of Lambda, that debugging and troubleshooting is cumbersome sometimes. So now let's move ahead, and yeah. So as we already know, Java virtual threads, in instance of Java thread, just like platform thread, they are not tied to any specific operating system thread. It runs code on operating system thread. However, when code is running in a virtual thread and it gets blocked due to some IO operation, what JVM does is it suspends virtual thread until it can be resumed. The OS thread associated with the suspended virtual thread is now free to perform operation for other virtual threads. So now scheduling is happening for one operating system thread level. Okay, so in platform thread, it was not under JVM's control. Now JVM gets to decide the scheduling part. Okay, this is very important. Virtual threads are implemented in a similar way to virtual memory. To simulate a lot of memory, an operating system maps large virtual address space to a limited amount of RAM. Similarly, to simulate a lot of threads, the Java runtime maps a large number of virtual threads to a smaller number of OS threads. So if you are aware of virtual memory concept, where the large memory is simulated, but actually you have very limited memory, something similar happens here. So you can simulate a lot of threads, but you actually have limited number of OS threads. Yes. So as we know, so far the virtual threads are very cheap to create and are managed directly by JVM. Operating system is not at all aware of them. Virtual threads are suitable for running tasks that spend most of the time blocked, often waiting for IO operations to complete. They are not intended for long running CPU intensive operations. So this is one of the pitfall. one should not be using virtual threads for long running CPU intensive operations. Neither The last point is also very important. They are not faster than platform threads. They do not run code any faster than platform threads. They exist to provide scale, higher throughput, not the speed. Okay. So whenever you have lot of operations where waiting code, you have written code which waits for some fetching data from any other microservice or any other external system. There you should be there. If you use virtual thing, then you will get better throughput. That is what it means. So finally, why one should use virtual threads once they are available? High throughput concurrent applications, especially those that consist great number of concurrent tasks that spend much of their time waiting, and server applications are good examples of high throughput application because they typically handle many client requests that perform blocking IO operations such as fetching resources. So if you have worked in microservices, you would understand this could be uh, very helpful in that context. Now let's understand why. So far we understood what were the goals to create Java virtual threads, but let's understand why. Let's not misunderstood. It is uh, let's discuss non-goals. Virtual thread don't mean to replace platform threads even in near future. It's not a goal to remove traditional implementation of threads or silently migrate to existing application to use virtual threads. That's not going to happen. In fact, the basic concurrency model is not going to change. At least as of now, that is what OpenJDK and Oracle is saying. And the Stream API, which we are using, it remains the preferred way to process large data sets in parallel. So this is very important. The Stream API remains the preferred way to process large data sets in parallel. Yeah. So now let's go to IntelliJ, and yeah. So in IntelliJ, I have created one project, Java concurrency. Let's configure Java 21 preview channel first. What I'm going to do is right click on this project. I'm going into open module settings. Here, first of all, I'm going into this platform settings SDKs. Here, first of all, if you don't have Java 21, so you can either download JDK from here, or you can add JDK if you have already installed. So whatever path you have, the path where you have installed Java JDK 21, you should enter path here. You should select that path here and click on OK. Then this will you will see Java 21 over here. Okay. Now you have to go. The next important thing is to enable preview channel. You need to go to project settings project. Here you need to select your SDK as Java 21, and then to enable preview channel, you have to select 21 preview. Okay. So that's it. And then if you click on apply, your preview channel is enabled. Okay. Now let's start. Let's see how to create simple virtual thread. Let's create runnable task 1. Let's use lambda. Hello virtual thread. Use virtual thread. It's the same class. What we do is we use thread dot start virtual thread task 1. We pass runnable, and then what do? We do vt dot start, and then we do vt dot join. All right. So yeah. So exception. Yeah. So let's run this program. Very basic example. Okay, so it is actually starting. So there is another method basically where you can say start virtual thread. Okay, let's see. First of all, okay, so this is correct. Let's quickly see how to start. I mean, we already know this, but I mean, there is another way. One should create platform thread. One can create platform thread using new APIs. sorry about that. Yeah, thread dot of platform, and then you can pass task 2, and then we can similarly we can start vt and vt dot join. Okay, so yeah, it should print. Acha, I have done same mistake here again. So it basically starts the thread, and if you want to create, yeah. So the confusion here is, yeah, it actually you don't have to call start, and if you want to just create it, okay, of virtual unstarted task 1, okay, then you have to call vt dot start, and similarly here what I can do is I can say I don't want to start now, I want to start it later on. So yeah, so it basically creates a runnable uh, thread, which when we call start method, then it will actually start running it. So in next video, we'll do some benchmarking, and we are also going to look at concurrency, structured concurrency model that is also available in this preview edition. Thanks for watching this video, and please like, share, and subscribe if you like this content. Thank you.